Hello students, welcome to this another session. Here I'm doing the physics analysis of the NEET test number 51. Today the paper came very late. I was getting call from the students that will the papers come or 50 is the limit. I told them the JEE main test has already arrived, so NEET test will also arrive. It arrived, and after a while it was downloaded, and as soon as it is downloaded I have solved it, and now I'm uploading for you. So now looking at this paper, this paper is slightly an easier one. As per me, 26 questions were quite easy, 18 were medium, one question I have, or two questions, sorry. So if I have two, so this would be 17, I think. So two questions were slightly difficult, you can say, and they were also not very difficult like this one. This here you had the 3 input combination of the gates, which you usually don't do. But the paper is really good, it's easy, and some questions are very beautifully asked. They are very good conceptual questions that should be the right questions for the NEET examination. So I was able to solve it quite easily. I was also rushing through because I solved the JEE main test because I thought today my paper might not come, so I might have rushed through this paper, so pardon me for that. Now based on this paper, I can say even a good score in this paper has to be higher. I say it should be 135 plus at least, and for a very good student, now this should be the paper you should be aiming for 160 plus. This is the paper where you can score even the max 175 or 180 score. This is the paper of that type. So let's see what you have done. Let's start the paper. So let's see what is in this NTA NEET test 51. We started the first question. The horizontal component of the Earth's field at any point is given. The angle of dip is given. Then the value of the vertical component. You know the angle of dip, tan I or tan theta, that is equals to BV upon BH. So the value of the B vertical would be equal to BH tan of I. And if I solve it, BH is what? 0.36 into 10 to the power minus 4, and 1060 is root 3. That is 1.73 times, and that means it would be less than 0.72, closer to that. So 0.62 into 10 to the power minus 4 I can directly make out from the given options. So this is the D1. So this is an easy one. Next one. In the given circuit diagram, current in the 2 ohm resistor, where it is 2 ohm? Yes, here. It is 2 ampere. Then the current in the 6 ohm, here it is. Okay. So just look at it. This complete combination is in parallel. This is 2 and 1 3. This 6 and 3 is 2. 2 and 1 is 3. That means the current will be equal. That means if it is 2 ampere, it means it is 2 ampere. Now this 2 ampere has to be divided into 3 and 6. So I through 6 would be equal to, in the inverse ratio, that is 3 upon 3 plus 6 into the complete current, which is 2 flowing through this branch. So that comes out to be 1 by 3 into 2. So that is 2 by 3 ampere. That's also an easy one, not very tough for you to solve. Next one, in every experiment with potentiometer in the null point state, the potential difference between the ends of the galvanometer is at the null point. You know it is balanced, so it is 0. No point in guessing. It's an easy one. Question 4. Let's see what it has. Consider the situation in the figure. If the switch is closed and after some time it is again opened, then the closed loop will show. Again, always remember, whenever the switch is opened, the current is reduced. It will have a tendency to get in attractive way. So first look at it. The closed loop will, first of all, देखिए, if switch is closed, when it is closed, the current is induced like this. So because of this wire, because it is the closer one, because of this, the field produced would be out, that is towards you. So to oppose it, initially the current that will be established would be the clockwise one, and once the current recedes, to support this outward field, the current will become anti-clockwise. So option D is the most appropriate. You can do that based on your EMI knowledge. In the circuit shown in figure, time constant and steady state current will be. Let's look at the circuit. This is there. Steady state current is quite easy. First of all, how to calculate a steady state current? In steady state, it will behave as a, what you say, in a steady state it behaves as a wire. So because it behaves as a wire, this 8 and 8 will become in parallel, that is 4 and 4 is 8. So the current in the steady state would be 6 by 8, that is 0.75 ampere. So this leaves that with one option, so no point in guessing. You can solve for the time constant also, but I have done it directly because there's only one option, so I can go for A. Now the sixth one. An electric dipole of dipole moment P is placed in a uniform electric field E such that P is perpendicular to E. The work done to turn the dipole through an angle of 180 degree is. Now P is perpendicular to E like this. This is P and this is E. Now work done to turn the dipole through an angle of 180. So if you rotate it by 180, it becomes like that. Angle was 90, it is still 90, so no change. So answer will be 0, no point. It's also an easy one. Next, look at the seventh one. A parallel plate capacitor charged by a battery. After charging the capacitor, the battery is now disconnected. That means Q is going to remain constant. Now, if a dielectric plate is inserted, then which is not correct? Because dielectric is inserted, you know C will increase. Q is going to remain the same, and hence you can directly say V is going to decrease. That is how I can know. Now see what are the options. Which one of the following is increase in the stored energy? So for the energy, I'll go for this formula Q square by 2C. If I go by Q square by 2C, since capacitance is increased, so that means the energy is going to decrease. So first option is wrong, so I have to select the wrong option. So it's say move ahead, no point in guessing other ones. You can check yourself. 8th, an electron flies into a homogeneous magnetic field of 10 to the power minus 3 Tesla perpendicular to the force line. Velocity is this, then the tangential acceleration of electron in the magnetic field. Now, because velocity is perpendicular to magnetic field, force is going to be perpendicular to V, force is going to be perpendicular to B. So because force is perpendicular to V, so there's no point, there's no force which is providing the tangential force, so acceleration in tangential direction is 0. So it's again an easy one. I'm just checking your basic knowledge. A particle of charge Q and mass m is projected with a velocity v0 towards a circular region having field B perpendicular and into the plane. From point P as shown in figure, if R be the radius and O is the center of the region, the line OP makes an angle theta with the velocity direction of v0, then the value of v0 so that the particle passes through. I have done this before also in one test, I can recall. So if it has to pass through like this, let me take the pencil. Yeah. So if I draw, it would be the center, this will be something like this. So this would be R, this would be R would be equals to, that I can directly make out mv0 by qb. Now, if this angle is theta, this is perpendicular to this is perpendicular, so I can directly make out the perpendicular I'll draw here will also be angle theta. So symmetry, this angle will also be theta, that can I directly say. So that means in this duration, first of all, I can make out this distance. I can say the capital R would be equals to R sine theta multiplied by 2. So that is 2R sine theta. So the capital R is going to be, if I put the value, what it will be, R is mv0, this is sine theta upon qb. Now, what is the value of v0? So you have to find the value of v0. So v0 comes out as qbr upon 2, what we have, m sine of theta. So what we have, if we can find out the option, we similar, yes, this is the B option. So this was also an easy one. Now the 10th one, not easy but it's a good question. Solar radiation by sun resembles that emitted by a black body at 6000. This is third time this is given. The temperature of sun is around 6000 Kelvin. Maximum wavelength, maximum intensity is around 4800 angstrom. If sun were to cool down to 3000, what would be the peak intensity? You know that lambda mt remains constant from the Wien's law. So if temperature is half, lambda will become double, so double of that, 9600 angstrom. So this is an easy one. If you are practicing NTA test, you should be very well versed with the Wien's law by now. Wien's law is actually very important in all examinations. The pressure of the given mass of a gas in a thermodynamic system is changed in such a way 20 joule of heat is released from the gas. The Q is minus 20 joule from our convention. 8 joule of work is done over it means minus 8 joule. If the initial energy is 30, what would be the final? So from the first law, I can say delta U is a Q minus W, minus 20 minus will become plus 8, so minus 12. So it will decrease by 12 joule to 30, it becomes 18 joules. So option C would be the appropriate one. Again, an easy one, basic application of the sign convention of the first law. An ideal refrigerator has a freezer at a temperature of minus 13. The coefficient of performance is 5, the temperature of the air at which heat is rejected. Ideal here means the Carnot one. Ideal here means the Carnot one. So coefficient of performance alpha. What we say alpha as QC upon W, or you can write it as QC upon QH minus QC, that you know. And because it is the ideal one, I can take the ratio as TC upon TH minus TC, because QC by QH is TC by TH. So that is alpha. So what we have till now, alpha is 5. Freezer is minus 13. Minus 13 means it is 260. So TH minus 260. Remember, always put it in Kelvin. Never do it in the Celsius. So what we have this now, this is 52. So TH minus 260 is equals to 52. So TH is 260 plus 52. So that will leave me with 312 Kelvin. 312 Kelvin, you can make it out, it is 39 degree Celsius. So again, an easy one, basic application of your, what we call it, the Carnot's theorem, Carnot efficiency, Carnot performance. Next, an ideal diatomic gas occupies volume V1 at pressure P1 undergoes a process in which the pressure is proportional to volume. If you have listened to my physics in 5-minute series, it should spontaneously get you that pressure is proportional to volume, so PV to the power minus 1 is constant, so X is going to be minus 1 for the polytropic process. At the end of the process, the RMS speed of the gas molecules has doubled. RMS speed has doubled, that means temperature has become 4 times. That means the product of PV will become 4 times, that I can say. Then the heat supplied to the gas in the given processes. So first of all, what would be the C? Just I told you, if you can identify polytropic, you can write it directly. CV dia means 5R by 2. X is minus 1, so plus R by 2, so that is 3R. So I can directly say Q is equals to NC delta T. C is 3R, so 3 nRT final minus nRT initial. T final is 4 times of T initial, so this becomes 3 times nR T initial, and nRT initial is P initial V initial, so 9 Pi Vi, so P9 P1 V1. So again, if you know this polytropic one, you can make it, otherwise you would feel difficulty in this. So that was the benefit of that physics revision in 5-minute series I launched. If a bimetallic strip is heated, it will if you just remember, let's tell you something like this. If this is a bimetallic strip, let's say this is alpha 1, this is alpha 2, and if I say alpha 1 is lesser than alpha 2, so if I heat it, alpha 1 will expand less, so it would be on the inner side, and alpha 2 will be more, so it will be on the outer side. So definitely it will bend. If we'll say it bend upwards, that means it bend towards the material which has the lower thermal expansion coefficient. It's an easy one. You definitely must have read that. Ice point and steam point on a particular scale. Again, say the temperature comparison scale question is there, 10 and 80 respectively. The temperature on degree Fahrenheit scale when the temperature on the new scale is 45. So just to get you an idea, the ice point is 10 degree here, which here you know is 32 degree Fahrenheit. Okay. Now what you have here, you have this one as 80 degrees, where you have this as 212 degree Fahrenheit. So here you had 180 divisions, and here you are having 70 divisions. So here 70 change, there is 180 change. Now 45. So for 45 here you have moved by 35 divisions. So because you have moved by 35 division, so here also you can directly say it will also be in between 80 plus 10 by 2. So this is also the average of this, 212 plus 32 by 2. That is basically what you have, 254 by 2. So 254 or 244, what do you have? 244, sorry, my calculation is not right. So 244 by 2, that gives you 122 degree Fahrenheit. It's an easy one because it's a midpoint, so it's become more easy. Now the question number 16, what we have, a string is tied at two supports. A pulse is generated on the string as shown in figure, minimum time after which a string will again regain its shape. It's very good question. Now see, after this first collision, it will become like this, so won't regain. Again after this collision, it will again get inverse, because you know when it is reflected from a rigid end, 180 degree phase change occurs, so the shape will reoccur after it completes the complete round. So complete round means 4 and 4 8, 2 and 2 4, to total 12 meter divided by 2, so it will regain the shape after 6 seconds. So if you are thorough in the concepts, it's not a tough one for you, it won't change you. 17, I was not able to take the screenshot at the time of questions, so I have taken the answer one. Now the motion of particle is non-uniform. You know the non-uniform motion means the velocity must change, either the direction change or the value change or the speed change. So it is all of the above. It is one of the easier ones. 18th, let's see. The particle is given an initial velocity this much. Cartesian equation of its path is. So the Cartesian equation of its path is I is the horizontal, j is along vertical upward. So this is a standard form. So you know that equation y is x tan theta minus gx square upon 2u square cos square theta. So you all are very well aware. Tan theta, so looking at it, tan theta is uy by ux. You can make it out, it is 2. So y is equal to 2x. If tan theta is 2, what would be the cos theta? If tan theta is, let's say, 2 by 1, cos theta would be equals to 1 by root 5, so cos square theta would be equals to 1 by 5. So g is 10, x square, 2u square. U square, if I do, that is 2 into u square, that would be 5. 4 plus 1, 5. Cos square theta you have got is 1 by 5, so it is cancelled. So 2x minus 5x square. So again, not a tough one. You do such questions many in your 11th class starting, so you can make it out. Next. The force of kinetic friction doesn't depend on the relative velocity of the two surfaces in contact. You know this because for small speeds we take it to remain same, whether the relative speed is 1 or 2. It depends on nature of surfaces. It depends on the normal reaction of the of the moving body, you know that. So this is A option is the most appropriate one. Next, to move ahead. Sphere of mass m moves with velocity 2v and collides inelastically with another identical sphere. So it is identical and inelastic. After collision, first moves with velocity v in a direction, not completely inelastic, in a direction perpendicular to the initial. Find the speed of the second one. So just remember, this is m, this is going with 2v. Let's say this is x-axis, and let's say this is y-axis. So after the collision, this is before the collision, after the collision it has gone perpendicular, let's say like this, mv. So definitely the second one will go like this. And to conserve momentum in x, it should have a speed 2v here, and to cancel the y component, because y initial is 0 momentum, so it will have v here. So its velocity will be, v2 would be, definitely you can say that is going to be root 5v. So it's again an easy one. You have done many questions like that, so no issues, I suppose. Next one, as observed in the laboratory system, a 6 MeV proton is incident on a stationary 12C target. This velocity of center of mass of the system is, so again what we will have, because the proton's kinetic energy is given, and we know VCM, we have that formula m1, m1 v1 plus m2 v2 over m1 plus m2. So if I do this now, so what we have, mass of proton is, let's say, m into v of proton plus mass of 12C is 12m, that you can take approximately, no issues. This is 0 divided by 13m. So you have this Vp by 13. So first of all is find out the velocity of proton. So what we have, half into 1.67 into 10 to the power minus 27 into Vp square is 6 MeV. MeV means 1.6 into 10 to the power minus 13. So it's good calculation for you. 6 into 1.6 into 2, 1.67, and if I take the powers, this is 10 to the power 14. Let's cancel it out. So Vp basically comes out as root 12 into 10 to the power 7. So what you have, root 12 into 10 to the power 7 divided by 13. Root 12 is 3 point something, and 13, if I do this, it is 2 point something. I can directly make it out. So this is 2.6 into 10 to the power 6, because this is 3 point something, and if you have to do with 13, one power will be cancelled. This is 30 something, so it would be 2.6 into 10 to the power 6. So again, a calculative one for the NEET aspirants, but whatever, every question cannot be a laddu. The object is projected with a speed 10 at an angle of 30 with the horizontal. It breaks into n equal fragments. One fragment strikes the ground at a distance root 3 from the point. Center of mass of the remaining fragment strikes the ground at a distance of 7 root 3 from the point of projection if all fragments strike the ground at same time. This is very important, because all are striking at same time, is the net CM will be at the original range. Find the value of n. So it's easy one, no issues. What we will have, the first one has a mass, let's say small m, it is landing at root 3. The other one, let's say, have the mass n minus 1 times m, let total mass be n m. They are striking at 7 root 3, so CM should strike at n times m, and that should be r original. So what we have, root 3 plus n minus 1 times 7 root 3 upon n, original range, you know, u square sine 2 theta by g. So if I do this, what I will have, I'll have, I'll keep it like this only. I'll solve this side. This is 100, sine 60 is root 3 by 2, and g is 10, so I can solve it. It is 5 root 3. Okay, so 5 root 3n is equal to n minus 1 into 7 root 3 plus root 3. So if I take this n1, this is 2 root 3n, and this would be 6 root 3, root 3 cancel, so n is equal to 3. So again, a calculative one, but not a very tough one for you. Now 23rd, what this question says, a ball goes with speed v, hits a massive wall moving towards the ball with speed u if the elastic impacts lasts for a time delta t. Now elastic collision, now you remember all this. This is v, this is u. You know, whenever it strikes with wall will continue to go with speed u. Initially they were approaching with a speed v plus u because they were opposite. So again the separation speed is v plus u, now both in same direction, so that v plus u would be added to u, so its velocity will become v plus 2u, so that the difference still remains the same. So now for the ball, initial velocity was v, final is this. So what is the momentum change of the ball? Momentum change of the ball is, now if I take this direction, final direction is positive, so I will have m into v plus 2u minus, and this will become minus mv. This is the momentum change. So what we have, m, it becomes v plus it's u. It becomes 2v plus 2u. Sorry, this becomes 2v plus 2u. Okay. So now this is the momentum change and time is delta t, so force is delta p by delta t. So you can directly make out average force acting on the ball is this much, and similarly this force is also exerted on the wall. So it's a standard way of doing the such questions. 24th, particle goes in a circular path and its acceleration vector is making an 30-degree with velocity. Again the same repetition. This is velocity, acceleration makes an angle 30-degree. So this would be the perpendicular one AC, this would be the along the one AT. So I can directly write 10 30-degree is equal to AC by AT. So what you need? Ratio of centripetal to tangential. This is what needed. 10 30. 10 30 is 1 by root 3. Go for option C. Again this is a repeated question. 25th. Find the work done to take a particle of mass m from surface of earth to a height equal to 2r. Again this is the question we are doing from many times. U final minus U initial. Final is what? Minus gmm 2r height. That means from surface it is 3r. Minus minus become plus. Initially it was on the surface. So what we have? If I simplify it, it comes out as 2 gmm by 3r multiplied by r and r. This gm by r square term, not 3 will be separate. Gm by r square small g, so this would be 2 mgr by 3. So you can directly go for option D. So it again a repetition of the same concept again and again in these NTA tests. What will they do? 51 papers, so the questions have to be repeated. A satellite which is geostationary in a particular orbit is taken to another orbit. The distance was one is twice that of earlier orbit. The time period in the second one, you know, t square is proportional to r cube. So tgo to t nu would be rgo upon r nu to the power 3 by 2, and this is 1 by 2 to the power 3 by 2. So the new time period is geostationary period into 2 to the power 3 by 2, that is 2 root 2 times geostationary means 24 hours. So it is 48 root 2 hours. So again a easy one. Again a repetition of the same concept again and again. Two identical springs are connected in parallel and series. FP, Fs are frequency. Then now you remember this. Now in the first one, in the series one, the K equivalent of the series one, you know, is of the parallel one, sorry, the first one is parallel, one is 2K. The K equivalent of series one, you know, will be equals to K by 2. Now frequency is, you know, 1 upon 2 pi root of K by M. So it is F is proportional to root K, so Fs upon Fp, that would be equals to root of K by 2 upon root 2K, that is equals to 1:2. So no issues, no problems. You have done such questions. 1:2. Go ahead. A particle goes through such that acceleration standard form of SHM you are taking. Time period, what do you have? You know, A is equal to minus omega square, x-axis displacement. So here this would be the mean position. And if I compare, omega is the root of beta, so time period is 2 pi by omega, that is 2 pi 1 by beta root. So it's an easy one, B option. You have done multiple questions like that. Next one, the volume of brick is 2.197 liters. Okay, submerged brick is balanced by 2.5 kg mass on the beam scale. The weight of the brick is okay. So what is the weight of the brick? So simply if I had to this is balanced here. So again this, let's say if I say this tension or normal, this would be mg and this would be buoyant force also. That T plus Fb, that should be equals to what we say, that is equal to I am assuming the lengths are same. Okay, that is what I am assuming, otherwise lengths would have been given. And this T is equal to, this is mass of brick into G I should write. This T is equal to M balanced wala jo hai, let's say small m, capital M likh dein. So this is mg plus Fb. Fb is rho of water into volume of brick into G, that is equal to mbg. So that mg would be equal to mbg minus rho w vbg. So what I have 2.54, so this is 25.4 minus, okay, you have to calculate the mass of the brick. I was calculating the mass of that, which is already given. So what we have, 2.54 into 10 plus rho w is 10 to the power 3, volume is 2.197, liters is 10 to the power minus 3 meter cube, and this is G, that is equal to mbg. So now we have 25.4, what we have, this is cancelled, plus 21.97 is equal to mbg weight. So what we have, this is 25 and 21, it is 46 plus something. You approximately have 46 point something, so 47 and something. So this would be the most appropriate option we can go for. Now go ahead. In a capillary tube, the water rises to a height of 4. If the cross-sectional area of the tube were 1/4, water would have risen to height. So what you know, H is equal to 2s cos theta upon rho g a. A is the radius. So if the cross-sectional area is 1/4, that means the radius is half. So radius is half, the height will become double. So it's an easy one, 8 centimeters. Next one. Figure shows a body of arbitrary shape. O is the cm and the mass is m. If ICC dash is equal to I naught. What is ICC dash? Okay, this one. What would be IAA dash? So I can simply use the parallel axis theorem. What I can say, ICC dash is equal to I about cm plus m into d square, and this is given as I naught. Okay. Now what would be IAA dash? IAA dash would be ICM plus m into d की जगह it would be 2d का whole square. So ICM I can take it from above, that is I naught minus md square plus 4md square. So that is sorry, not that one, this is not the right way. It is I naught, I naught is ICC. Okay, it is okay, so ICC plus 3md square, no issue. So it is the correct one, C option. Now just remember, you cannot write this as this one plus md square. The reference one has to be through the cm. That is what you have learned in the parallel axis theorem. Now going ahead, a man of mass capital M stands at one end of a plank of length L which lies at rest. If the man walks to the other end, if the mass of the plank is 3m, the distance of the man that moves relative to the ground. You have done this question multiple times. This is the plank, this is the man. So if the man goes relative to the plank like this, and let's say plank shifts backwards, we know, let's say it shifts backward by distance x. So it is, if shift is by x, the actual distance moved by man in ground frame would be L minus x, plus what is the distance displacement of the plank, 3m minus x, divided by the total, that is the shift of cm, and because no external forces there, cm won't shift, so this is 0. So what you have, m L minus x is equal to 3mx. So x would be equals to ml upon 4m, that is L by 4. So x is L by 4, so plank shifts by L by 4. So relative to the ground, man moves by L minus x, L minus L by 4, that is 3L by 4 distance the man moves relative to the ground. Now going ahead, the path of the scattered alpha particle is, so the scattered alpha particle is, basically we say it is a hyperbolic. That is what you have learned. It is not circular, it is parabolic, not elliptical. So because, and the force is always a, what we say, it is a central force. So because of that, it goes in the hyperbolic path. You must have drawn that figures in your NCERT is also given the path of the trajectory of the alpha particle. Now hydrogen atom is in the fifth state. When the electron jumps to ground state, the velocity of the recoiling, now it is in fifth state. So because it is in fifth state, we know the energy of the fifth state is minus 13.6 by 5 square, that is divided by 25, which basically I can remember minus 0.54 eV, and in the ground state is minus 13.6 eV. So the change in the energy, what is, we have the change in the energy that we have, the difference of the energy would be 13.6 minus 0.54, so it is approximately 13.06 eV. So this is the energy of photon. So the momentum of photon is 13. E by c, that is 13.06 ev by c, and that should be equal to mass of the hydrogen atom into recoil velocity of hydrogen atom. So velocity of hydrogen atom would be 13.06 into 1.6 into 10 to the power minus 19 divided by c, 3 into 10 to the power 8. Hydrogen, you can take mass approximately as 1.6 into 10 to the power minus 27. Cancel it out. What you have, this cancel. This is 4 point something meter per second, so approximately it would be 4 or 4.2, whatever you can make out depending on what you're doing. So it is 4.2. Now the energy of helium plus ion in the first excited state. Now the energy in the first excited state, what we write it as E2, going by the Bohr's result, minus 13.6 z square by n square. So minus 13.6 into z is 2, so 2 square, n square, 2 square, so this is minus 13.6 ev. No point in guessing, it's an easy one. Light of frequency 1.5 times the threshold 1 is incident, photocurrent is emitted if the frequency of the light is halved. If frequency is halved, just remember, now here the energy of photon is 1.5 times the phi. So if it is halved, it becomes 0.75 times phi, so it is less than phi, so no photoelectric effect will occur, so the current will be shunya, 0. So it's a conceptual one. Next, what is the force exerted by a photon of intensity if it falls on a perfect absorber? So because it is falling on the perfect absorber, the radiation pressure I will write it I by c. So force I will, So the force is going to be IA by C. What has I? 1.4 into 10 to the power 3. Area, perfect absorber, so we're taking it as a sphere, so it would be 4 pi r square. 4 into 3.14 into 2 square upon C, 3 into 10 to the power 8. So if I do this all calculations, what I'm going to have, 8 and 3, 10 to the power minus 5. 4 into 1.4, that is 5.6 into 3.14 into 4 upon 3. So approximately it is 20 plus crossing to 2 point something into 10 to the power minus 4 should be the answer. So it's option A we can go for. So just remember, for a perfectly absorbing surface, radiation pressure is I by C. For perfectly reflecting, it is 2I by C. For a perfectly reflecting question, it was in today's JEE main test that I solved in the morning, early morning. Now this one. The logic gates shows 2 NAND gates followed by a NOR gate. The system is equivalent to the following logic gate. So again, what I have here, so just remember we have 3 inputs. Normally we are not dealing with 3 input gates, but let's see what we can do here. Just start by taking all 3 0. So all 3 0, this is the NAND, so 1 and 1, so it would be 0. So 000 will give me 0, and if I, let's say, keep A as 1, keeping this, so 1 0 0, so what we have, 0 0 0, it is 0. Now I am having 1 0 0. So for 1 0 0, again 1 and 0, this would remain the same, so 0. So similarly, if I take C as 1 and A as 0, B as 0, this will again remain the same. Now if I take B as 1 and keep rest 2 as 0, so again the result will remain 0. So I can easily make out it would be 1 only if both are exactly 0. So for both 0, this ANDs must be 1, so NAND should be 0. So only 1 1 1 is going to give me 1. So it is basically a AND gate. It won't be 1 unless all 3 are 1. So you can make it out, though we don't do 3 input gates usually. So it would be slightly tougher for you, not an easy, not very tough, I can say. Current gain alpha is this, the gain beta. So you know beta you know is alpha upon 1 minus alpha. That is only thing you can remember easily in the transistor thing. So what you have, 0.995 divided by 0.005, so 995 over 5. So what we have, 149.9, 199, option C. So again it's the easy one from the transistor. The EB junction, again transistor of a transistor is, so in normal operation EB is forward bias and the collector base junction is reverse bias while we are operating in the, let's say, the linear part, or you can say the active region. So it is a easy one for you. You remember this basic working. Again transistor, oh my god, again NPN transistor, 10 to the power 10 electron enters in emitter region. In this, 2% are lost in main, the collector current and current amplification factor. So first of all, see, 10 to the power 10 enters in. So what I can say, current would be 10 to the power 10 into 1.6 into 10 to the power minus 19 upon 10 to the power minus 6, and this is emitter current. So what we have, this is 6 and 10, 16, 10 to the power minus 6 into 1.6, so 1.6 milliampere, that is I have. Now 2% are lost, so therefore directly I can say collector current would be 0.98 times 1.6 milliampere. So 0.98 times 1.6, it will be very close to it. I can directly say 1.57 milliampere. And if I had to do that beta I can say is IC by IB, that is 98%, that is 2%, so that is 49. So option A is the most appropriate one. Again, and not a tough one. Question language is good, but you can make it out. When a picture drawn on paper is seen through a slab of transparent material thickness 5 cm appears to be raised by 1.5, the critical angle at the boundary of this transparent. So what we know, the shift that generally we talk about is T minus T by mu, or N, what you write. So 1.5 is 5 into 1 minus 1 by mu. So 3 by 10 is 1 minus 1 by mu. I'm right, yes, 1 by mu is 7 by 10, so mu is 10 by 7, and you know the sine theta c for such a material is again 1 by mu, that is 7 by 10, so it's a sine inverse 7 by 10. So you just have to remember that shift and you can easily make it out. Next one, a ray of light when incident upon a prism suffers a minimum deviation of 39. If its shaded half portion of the prism is removed, then the same ray will, now this would be a good one. So what will happen, you know, for the case of minimum deviation, the ray in this passes symmetrically. Let's say this is parallel to this one. So if I remove this, there is no deviation occurs only at one surface. There the deviation was occurring at both the surfaces, and you know in the symmetry region the both parts were doing equal deviations. So here the deviation will only be 19.5 degrees. So very well thought, made out question, very good question. I just like that question, very well asked from the NTA. 44th, The total angular width of central maxima in diffraction of a single slit is, you know, that is 2 lambda by, nothing special about it. You directly remember this. When an polarized beam is incident from air onto glass at polarizing angle, when you apply it at Brewster angle, the reflected light is completely polarized. So reflected light is completely polarized. So this was the test number 45. Today I might be a little fast because the paper was uploaded late, and because of that I have to solve the JEE main test in the morning, and now that because of the time crunch, today I might have hurried through the paper, but you can make out the paper was not easy. If I can hurry it without seeing anything, so you can also do this paper was easily doable in 1 hour. So thanks for watching. Keep sharing, keep liking, keep giving your feedback, suggestions, and do watch my physics in 5-minute revision series.